so today we are going to discuss about Coulomb's law. So before going with the Coulomb's law, first of all let me tell you that who discovered the Coulomb's law. The name of that scientist was basically Charles Austin de Coulomb. And when it was given in 1785. Okay, so what does the Coulomb's law tell? First of all, for discussing the Coulomb's law, you have to know what is electrostatic and electrodynamic. So here electrostatics. So here electro means charge. Electro means charge and its static means rest. The charge which are in rest. Now talking about electrodynamic. Electrodynamic. So electro means charge, while dynamic means motion, the charge in motion. So now let me tell you the concept of attractive and repulsive force. So as you can see here, we have two charges. This is positive and this is also positive. So as we all know that the same charges always repel each other. So these both are positive, same charges. So here there will be the repulsive force. Repulsive force means they will repel to each other because always same charges always repel each other. Now talking about the attractive, here we have positive charge while here we have negative charge. So always different charge always attract each other. So what they will attract each other? Okay, attractive force. Different charges always attract each other while same charges always repel each other. So now let's discuss about Coulomb's law. So Coulomb's law state that electrostatic force between two charges. So let me write here electrostatic force between two charges. So here as you can see here we have number 1, let me write here Q1 and Q2. Here we have two charges. What they are saying, electrostatic force between two charges. Here the force will be electrostatic force. Okay, so electrostatic force between two charges is directly proportional to the product of magnitude of charges and inversely proportional to square distance between them. So what this is saying? So here it is saying the force between two, electrostatic is the force between two charges. So here I draw the two charges. So in between there is the electrostatic force which is directly proportional to the product of magnitude of charges. What they are saying, the electrostatic force is directly proportional to product of magnitude of the charges. These are the product of magnitude of charges, okay, which is directly proportional, and inversely proportional to the square distance between them. What inversely proportional? Like here we have directly proportional between charges and inversely proportional between the square distance between them. Okay, so this is what Coulomb says. Let me write here: the electrostatic force directly proportional to the magnitude of to the product of magnitude of charges, this is charge 1 and charge 2, and inversely proportional to square distance between them. So here our Coulomb's law equation is, for formula we can say is. So now to remove this directly proportional sign, we will put the constant F is equal to K. Here we put the K constant, Q1 Q2 upon R square. So let me tell you, here F is denoted by the force, while Q1 Q2 are the charges, and R1 is the distance between them. And K is the Coulomb's constant. So now here the Coulomb's constant value is basically 9 multiplied by 10 raised to power 9 Newton meter square per Coulomb square. Now let's write this unit, how this unit came. Okay, so let's take the formula of Coulomb constant. Coulomb's law, F is equal to K Q1 Q2 upon R square. Now here the R square is dividing, there will be multiply. R square F is equal to K Q1 upon Q2. Now K, we have to find the K's value. K is equal to R square F upon Q1 and Q2. Now as you can see here, like here we have this. Now F unit is Newton. Now R we have meter, so meter square. Now upon here we have two charges, Q1 and Q2. These both are two charges. So here we have Coulomb square. When this will move up, that will be Newton meter square per Coulomb square, or you can put over like this. This is also right. Newton meter square Coulomb square. When it will move up, there will be negative charge. So this is how we put the unit over here. Now let's try how this K value, Coulomb constant value come. Okay. So here we have like K is equal to 9 multiplied by 10 raised to power 9 Newton meter square per Coulomb square. Now here we have another formula, that is K is equal to 1 upon 4 pi epsilon is equal to 9 multiplied by 10 raised to power 9 Newton meter square per Coulomb square. Now here what is this epsilon? It is basically the permittivity of free space. Okay, so the value of this epsilon is 8.85 multiplied by 10 raised to power minus 12 Coulomb square per Newton meter square. Okay, so now here we have like this, K is equal to 1 upon 4 pi epsilon and ER. So now here what is ER? It is basically the relative permittivity. Okay, so here we have like this Now let's put the values over here. K is equal to 1, 4. Now pi values we know 3.142. Sorry, 3.142. Epsilon we know 8.85 multiplied by 10 raised to power minus 12 coulomb square per Newton meter square. Okay, so here we have K is equal to 1. When we divide or multiply these all, the answer will be 11.156. So I give 3 ones. 6. Now here you can see here after dividing this both, the value came 8.99 multiplied by 10 raised to power 9 Newton meter square per coulomb square. Now 8.9, when we round off this, it will be around the 9 multiplied by 10 raised to power 9. So here we prove that K is coulomb constant is equal to 9 multiplied by 10 raised to power 9. Okay, so here we have some assumptions of Coulomb's law. Assumptions of Coulomb's law. So first we have like Coulomb's law is always applicable for the point charge. Always applicable for point charge. Point charge. Now you will be thinking that what is point charge? Okay, so point charge are those which have, let me write here, point charge. Okay, if those physical appearance of the charge is small, but the distance between them should be greater, you can say. So like what? So I am telling here like the physical appearance, the size of the charge should be small as compared to distance between them. The distance should be greater than the appearance size of the charge. Okay, so this is distance, this is charge q1, q2. Okay, so now the second point, it says that single point charge never exists. What? Single point charge never exists. What does it means? Like here we have one charge q1, so it will never exist. If it will be second charge, so it will exist, otherwise it will never exist. Okay, single charge will never exist. So it's a third point, it says like this: point charge always with respect to second charge. Point charge will be always with respect to second charge, never exists single charge, single point or single charge. Now number 4 point, last, that is it is always applicable for the stationary charges. What? Applicable for stationary charge. So now you might be thinking that what are stationary charges? So the charges which produce electric field surrounded by the electric charge. Surrounded by electric charge. Like here we have one charge. Okay, so the electric field, like the region around it is created, that is created by the stationary, known as stationary charge. So this region is basically known as electric field. Okay, so these were somehow points, assumptions, and how we derive the constant value, and the introduction on Coulomb's law. Hope you got it.